Hi students, today in this video I will explain one of the important topic, that is the valency and oxidation state. Most of the elements do not occur as a free state, especially the elements in the S block and the P block. Those elements are available in the combined form. Why? Because they are formed as a ionic or a covalent compound. The combining capacity of an element is called as the valency. The combining capacity of an element is often compared to that of the hydrogen, chlorine or oxygen. The valency may be defined as the valency of the element is the number of hydrogen atoms or the number of chlorine atoms or double the number of oxygen atom that can be combined with one atom of that element is called as the valency. Once again I am repeating, the valency of an element is the number of hydrogen atoms or the number of chlorine atoms or double the number of oxygen atoms that can be combined with the one atom of that element is called as the valency. Valency of an element not always constant, and some elements they are exhibit more than one valency. Those type of the elements are called as the variable valency. For example, if I am taking iron, iron is available in two different type of valencies, that is the Fe plus 2 and Fe plus 3. So this type of the elements we are called it is the variable valency containing elements. Now here maximum valency of S and P block elements are equal to the group number, and the highest oxidation state shown by the element is the 8, that is the osmonium, or maybe in the osmonium, or maybe in the xenon, or maybe in the ruthenium. So osmonium is available in the OSO4 and XeO4 and RuO4, and here in the OSO4 meaning here they have the 4 oxygen, and each and every oxygen valency is the 2, and they have the 4 oxygen, 4 into 2, 2 into 4, that is the 8. So total oxygen valency here 8. So the opposite valency of osmonium is the 8. So highest oxidation state is the osmonium. Along with that xenon tetroxide XeO4. In the XeO4 also the oxygen, they have the 4 oxygens are present, and each and every oxygen valence is the 2. So 2 into 4, the total oxygen valency here 8. So that here xenon valency also 8. Okay students, and here and some of the elements their oxidation states I will explain. And group number of valency electrons and valency. If the group number is the 1, and that element will be group number is the 1 and number of electrons is the 1 and the valency also 1. And the group number 1, the number of electrons also in the valence shell is the 1 and the valence is the 1, and the group number is the 2, number of valency electrons also 2 and the valence is the 2. And group number 13th, in the 13th group elements, and number of valency electrons are the 3 and valency also 3. And 14th group elements like a carbon family, and number of valency electrons are the 4 and the valence is the 4. And 15th group element, number of valency electrons are the 5. And in this time these elements it will be show two types of valencies, either 3 or the 5, or 3 or the 5. And 16th group elements, that is the oxygen family, the valency electrons are the 6 and the valency is either the 2 comma 6. That meaning these elements are show variable valency, either the 2 or the 6. And the 17th group elements, the valency electrons are the 7 and valency is either the 1 or the 7. And 18th group elements, valency electrons are the 8 and valency is either the 0 or the 8. So with the help of this table I will explain one more table. Once you can watch that. In the formula of hydrates and the group number and the formula of hydrate and the formula of oxide, just here I am taking 3 columns, and the group number 1. So first group elements are nothing but lithium, sodium and potassium and rubidium and cesium. So here if the lithium is binding with the hydrogen, it will form lithium hydride, and here the lithium valency is the +1 and hydrogen valence is the -1. Along with that the sodium is combined with the hydrogen to form sodium hydride, and sodium valence is the 1, and here hydrogen valence also 1. And the potassium react with the hydrogen to form potassium hydride, and potassium valence is the 1 and hydrogen valence is the 1, either plus or minus, whatever may be, as 1 and 1. In case in the second group elements, most probable cases the second group elements will be exhibit plus 2 valency, and here the calcium react with the hydrogen to form calcium hydride, and here the calcium valence is the 2, whereas the hydrogen valence is the 1. That's why here I am writing 2 hydrogens. Each hydrogen valence is the 1. If I am writing 2 means 2 hydrogen valence are the 2, so it will form like a calcium hydride. And the 13th group elements like a boron, aluminum, like that. The 13th group element, most probable cases it will show plus 3 valency, and boron B2H6. In the B2H6 they have the 6 hydrogen. Each and every hydrogen valence is the 1. Each and every hydrogen valence is the 1. How many hydrogens are there here? 6 hydrogens. So the valencies, total valencies of hydrogen is the 6. How many borons are there? There are the 2 borons by 2. So here the boron valence is the 3. Here the boron valence is the 3. And next one, silica. Next one, sorry, carbon. In the methane CH4, the carbon valency is the 4. In the carbon valence is the 4. Whereas in the silicon, and the silicon binding with the 4 hydrogens, and here also the silicon valence is the 4, along with the selenium and the tin. Here the 14th group elements will be show plus 4 valency, and the 15th group elements like a nitrogen. In the nitrogen they are binding with the 3 hydrogen to form nitrogen trihydride, and here each and every hydrogen valence is the 1, whereas the nitrogen is the 3. Why? Because 3 hydrogens are binding. Whereas in the phosphorus binding with the 3 hydrogen to form phosphorus trihydride, and here also the phosphorus valence is the 3, along with the arsenic and stibbium. In the water, in the 16th group element, most probable cases in the 16th group elements will be exhibit 2 valence is the common, and here the oxygen is binding with the 2 hydrogen. Already you know that the oxygen valence is the -2 and 2 hydrogens are combined, so that the oxygen valence is the 2. So the 16th group elements are commonly shown about the 2 valency. And 17th group element, hydrogen fluoride. Do you know that here the hydrogen valence is the +1 and fluorine valence is the -1. So the 17th group element commonly show valence is the 1. So 17th group element is the valence is the 1. Why? Because it is binding with the only one hydrogen, along with the hydrogen chloride, hydrogen bromide, hydrogen iodide. Here the 17th group element will show 1 valency, -1 valency. Next one, in case if it is form the formulas of oxides, and lithium react with the oxygen to form lithium dioxide. Why? Because here lithium valence is the only +1, whereas the oxygen valence is the lithium react with the oxygen to form Li2O. Why? Because lithium valence is the +1 and oxygen valence is the -2. That's why 2 plus ions are binding with the 1 oxygens, whereas the sodium react with the oxygen to form Na2O, and here also the sodium valence is the +1. That's why 2 sodiums are react with the oxygen to form sodium oxide. And if the potassium react with the oxygen and will form like a K2O or the KO2. In the KO2 the potassium valence is the +1, whereas the oxygen valence is the -1/2. Here it will show the fractional value. And the magnesium react with the oxygen to form magnesium oxide, and here the magnesium valence is the +2, whereas the oxygen valence also -2. In the calcium react with the oxygen to form calcium oxide. Here the calcium valence is the +2, whereas the oxygen valence is the -2, along with the strontium oxide also. In the B2O5, and they have the total oxygens are the 5. So total valency of oxygens are the 10. How many borons are there here? They have the 2 borons. So here the boron valence is the 5. Already I explained in the previous time. in the 13th group element, it will show as a 3, either the valence is a 3 or the 5. That's why in the boron pentoxide, so valency of the boron is the 5. Along with that, Al2O3, in the Al2O3, aluminum valency is the 3. Why? Because they have the 6 oxygens are present, 3 oxygens are present. Each and every valency of oxygen is 2 into 3, that equal to 6. And how many aluminiums are there? They have the 2 aluminium, so aluminum valence is the 3. Along with that, germanium oxide also. And next one is the carbon dioxide. In the carbon dioxide, carbon valence is the +4, whereas the oxygen valence is the -2. That's why 2 oxygens are combined to form carbon dioxide. Along with that, silicon dioxide and germanium oxide, same like that only. Once you can look at here, in the N2O3, there are the 3 oxygens are present. Total charge or the valency of oxygens are the 6. 2 into 3, that is 6. And how many nitrogens are there? There are the 2 nitrogens by 2. So total valency of nitrogen here 3. But in the N2O5, total oxygens are the 5. 5 into 2, 10 valency. And how many nitrogens are there? They are the 2 nitrogens. So here the nitrogen valency is the 5. Here nitrogen valency is the 5. In the P4O6, and total number of oxygens are the 6. 6 into 2, 12 is the valency, and 12 divided by 4. And here the phosphorus valency is the 3. But whereas in the P4O10, so they have the 10 oxygens. 10 into 2, 20 is the valency, and total number of phosphorus are the 4, and 4 divided by 20, that equal to here the phosphorus valency is the 5. In the sulfur trioxide, the oxygen valency is the -2, but the sulfur valency is 6. And the selenium trioxide also like that one. And here in the Cl2O7, and they have the 7 oxygens are there. 7 into 2, that equal to 14 is the oxygen valency. 14 divided by they have the 2 chlorines, 2. So here in the chlorine valency is the 7. And next I will explain about the oxidation state. The possible charge with which an atom appears in a compound is called its oxidation state. The possible charge, what the charge is getting, that is the oxidation state. Now in this video I will explain each and every element, what is the oxidation state it will appear. And first one, most of the S block elements, it will show the valence is equal to the group number. For example, the first group elements like a lithium, sodium, and potassium, and rubidium, and cesium, and francium will be show +1 valency. Along with that, alkali earth metals like a beryllium, magnesium, and it will show +2 valency. And most of the elements in the atomic form or the molecule form, the oxidation state is the 0. For example, in the H2 or the O2 or N2 or the Cl2, the oxidation state of those elements are the 0. And p block elements, they will show multivalency. The p block elements, they will show multivalency due to the reactivity already we were discussed in the previous time. So p block element will show multivalency. So we are not clearly say that the valency of the p block we are decided depending upon the combination. And oxidation state may be having either the positive or the negative or the fractional value. In case and potassium superoxide, and here the potassium valency is the +1, but whereas the oxidation state of a oxygen is -1/2. So here the oxidation state may be either having the positive value or maybe the negative value, maybe it is the fractional value. In the fourth A group element, or the fourth A group element, +2 oxidation state is more stable than +4 in the lead. So due to here it is the inner pair effect. And the element in the fifth group element, in the fifth group elements, it will be show the valency is either the +5 or -3 oxidation state, or +5 or the -3 oxidation state. In the general, in the sixth group element will be show -2 oxidation state. In the sixth group element it will show the minus oxidation state. But whereas in the oxygen in the peroxy bond like a H2O2, oxygen in the peroxy bond like a hydrogen peroxide, and here the oxygen will be show -1 valency. In the O2F2, in the OF2, here also the oxygen will be show -2 valence, plus 2 valency. Why? Because in the OF2 molecule the oxygen is having low electronegative value than the comparable to the fluorine, and oxygen electronegativity is the 3.5, whereas in the fluorine is the 4. In this time the oxygen is acting as a +2. So once again I am repeating, generally the oxygen family will be show the valence is the -2, but whereas in the peroxy bonds, the oxygen will be show -1, whereas in the OF2 the oxygen will be show +2 valency. In the superoxides like a KO2, in the potassium superoxide, and here the oxygen will be show -1/2 valency, that is the fractional value. Okay student, and whereas in the O2F2, and here also the oxygen will be show +1 valency. The most electronegative element is the fluorine. The electronegativity of the fluorine is approximately 4, and fluorine is show only -1 oxidation state in its compounds. And the common oxidation state of the D block elements are +2. The common oxidation state of D block elements are +2, and here all the D block elements will be show variable oxidation state, but the common is the +2. And in the D block elements like a chromium, like a copper, like a silver, like a gold, like a mercury, these elements shows +1 oxidation state, like a chromium, copper, silver and mercury. These elements are shows +1 oxidation state. The common oxidation state of a block elements are +3. The common oxidation state of a block elements are +3 due to outer shell electronic configuration. So it's the NS2 N-1 D0 R1. So here in the valence shell they have the 3 electrons. That's why in the F block elements generally we are representing the electronic configuration, so oxidation state is 3 or the +3. So maximum oxidation state of the elements never exceeds a group number. So the maximum oxidation state of an element never exceeds the group number. For example, if I am taking the 18th group elements, the 18th group element or 8th group element, the oxidation state may not be exceed more than 8. For example, XeO4, and here the oxygen, in here the xenon valence is the +8. So this is about the valency concept. If you like my video, give me the like and don't forget to subscribe my channel. Thank you.